The ultimate version of MecaStack has an option to design a dual wall stack, where the internal riser is often called a liner. On the main screen, there is an option at the top for auxiliary risers. On that drop-down, select Liner. Here there are many buttons that allow you to enter all aspects of the liner. Each button opens input windows for different aspects of the liner. These inputs are identical to what we covered previously when entering the main stack, and so refer back to those videos for explanations on each. However, a couple of the inputs are slightly different on liner, and so we will cover those differences now. The Settings button opens a window that allows some general settings to be specified. The name of the riser is a unique name that will be used throughout the analysis output to identify calculations specific to the liner. It should generally be less than a few characters long to make for a more concise output report. Next, we specify if the liner stiffness will contribute to resisting the lateral loads on the system. Some design standards specifically indicate that the liner should not be considered to resist lateral loads, and so it is generally the more conservative approach to leave this option unchecked. Even if unchecked, the deflection of the main riser will be considered to be imposed on the liner, and the resulting stresses from those imposed deflections will be calculated. Please refer to the article published on our website for dual wall stacks, which discusses the analysis performed in greater detail. The stack geometry inputs are identical to what was specified for the main stack. However, there is a new option here that allows us to specify the bottom elevation of the liner. When the bottom is above the bottom of the stack, the model will consider a rigid link back to the main riser. However, the actual support of the liner will not be designed, that must be performed outside of MecaStack. The top of the liner may also be higher than the main stack, so that the liner extends above the top of the stack. When this occurs, the software will automatically consider the portion of the liner extending beyond the top of the stack as being exposed to wind loads. The supports window looks similar to what was used for the main stack, but its functionality is different. In this instance, the support refers to the support that the main stack is providing to the liner. A fixed support means that a moment-resisting connection is formed between the main stack and liner. A guide indicates that a lateral support is provided between the main stack and liner. If a fixed support is indicated at the bottom of the stack, then the loads are transferred into the main stack and then the base plate. The design of the base plate with regard to the liner is not considered. That connection must be designed by the user outside of the MecaStack software. Breech and nozzle connections may also be specified, similarly to those on the main stack. However, if there is a connection on the liner that penetrates or passes through an opening on the main stack, both nozzles or breech must be entered independently. One nozzle on the liner would be specified, and then a corresponding nozzle on the main stack would be entered. The software does not automatically consider the relationship between these two connections and consider any radial or longitudinal differential thermal expansion. In general, the software does not consider tolerances or interference between the liner and main stack. The graphics will give some visual clues when there are problems, but please do not assume that the software will address all potential interference issues that might occur. When the riser is complete, you will see a graphic representation of the liner with the main stack transparent so that the liner can be viewed. When the liner is saved, the main graphic is then updated to include the liner. When the analysis is performed, the output then segregates the results from the main stack and the liner. In this example, the names of stack and liner were assigned, and so the output uses that same naming convention. You may check the main stack and liner stresses and deflections. The connectors between the liner and stack are in the section called Connectors, and here you can find all forces on the connectors that can be used for your detailed connector design. One thing you will learn quickly is that getting all checks to pass can be difficult. The analysis is complicated and changes can sometimes have unintended consequences. The location of the connectors can play a big role as well as the dimensions and thickness of each riser. Please take these things into consideration when making changes to the model in order to address specific deficiencies.